Okay, we're ready to begin our tech talk today. Make the switch to Solid Edge. Now, questions will be answered live at the end, but please go ahead and enter them in the chat as they come up. Our presenter today is Aaron Creech. He's based in our Cincinnati location. He's been with Prolim for 6 years. Aaron has over 20 years experience in design engineering field, including work in mechanical, environmental, architectural, and automotive industries. Aaron's design experience has ranged from concept design, product development, all the way through product procurement, including manufacturing process and refinement. Extensive experience using various 3D design packages. Aaron, the Tech Talk is now yours.
Thank you, Vicki. Hello, everyone, and thank you for attending today's monthly Siemens Solution Tech Talk. So today we're going to be discussing how Solid Edge makes it easier than ever before to transition from another CAD system to Solid Edge. So all while preserving your history-based modeling data. So let's kind of look at what we've got going on for today. So obviously the agenda for today will be kind of answering why would we switch to Solid Edge over other options out there. And then we'll briefly touch on the kernel craze, as I like to call it, some kind of active discussions that are happening in the CAD world today. And then we'll look at some basic workflows of how Solid Edge can handle data migration and translation of data from other CAD platforms back into Solid Edge. And then we'll look at some tools that help us transition from another tool into Solid Edge. And as Vicki mentioned, at the end, we'll do a Q&A at the end of the session. So if during the presentation you have questions, feel free to add them in the chat, and then we'll get to those questions when we get to the end of the presentation. So let's start by just kind of giving some basic information. Solid Edge is a key part of the Siemens Accelerator portfolio, and it focuses on the requirements of the small and mid-sized manufacturers. Solid Edge enables manufacturers to create a comprehensive digital twin of their products and include solutions for mechanical design, electrical design, simulation, manufacturing, and technical publications. It also includes simulation or solutions for data migration or data management for all the technical data that is being created and consumed when supporting the comprehensive digital twin. It facilitates collaboration both within manufacturing companies and with those external resources, including suppliers, customers, and vendors. So Solid Edge is the on-ramp to that digital transformation. The Siemens Accelerator enables customers to create their own comprehensive digital twins, flexible and adaptable to their own unique requirements and business models, using data and insight to predict and adapt products to the future needs. The Siemens Accelerator also enables an open ecosystem supported by rapid application development platforms to easily build, integrate, and extend existing data and systems. Only Siemens Accelerator has the breadth and depth of this software design tools spanning all the engineering domains, cloud services, IoT, native and cloud connected products, and app platform, enabling the only true comprehensive digital twin in an open ecosystem. So let's clarify a few things just to start. So both SolidWorks and Solid Edge use the Siemens Parasolid geometric modeling kernel for 3D modeling. This gives an immediate and high level of compatibility for your critical design data between the two systems. So we can open SolidWorks files directly inside of Solid Edge, and then we have no loss in the exact mathematical boundary representation or BREP definition of your 3D model. Both SolidWorks and Solid Edge are Microsoft Windows native applications, so they both have this similar look and feel of Windows between the two user interfaces. Ribbon bars to guide users through common tasks, tooltips to quickly identify these commands, and then the comprehensive in-application help dialogues. So these are all kind of things that help us kind of move and transition between the two. So the big question is, why would I switch to Solid Edge? So while switching 3D CAD software platforms may seem like a massive undertaking, continuing to rely on existing platforms for sake of convenience can cost you valuable time, money, and resources. So if you recently considered switching platforms or not completely satisfied with your current workflow, here are some top 10 reasons why switching to Solid Edge might make sense for you guys. So we'll start with number one, improved design documentation. So we can easily exchange information between engineers, suppliers, and manufacturers with a robust set of 2D and 3D drawing tools. Designers can create drawings directly using 2D workflows delivered from 3D models or a hybrid approach. With model-based definition or MBD capabilities, the 3D models include PMI and other digital design data using universal 3D PDF documentation. So users can access and view interactive representations of the manufacturing data without even having the CAD tools. Faster assembly performance. So don't waste time recreating or duplicating lost work or waiting for the assembly to load. Solid Edge allows designers to seamlessly work across large assemblies in real time with an uncompromised, immersive digital experience. So thanks to its high performance and seamless usability, designers realize productivity gains with Solid Edge as they work with their designs. So views can be manipulated in larger assemblies without any kind of lag, stuttering, or buffering. And then we have immersive view styles that place your 3D assembly models in a real-world environment that automatically updates when the model is zoomed in and out or rotated to really improve that realism look and feel. So number 3, we have less time remodeling and creating. So don't recreate the 3D models to match data from scanners, printers, or finite element models. In conjunction with powerful 3D design tools powered by synchronous technology, Solid Edge delivers smart functionality to work with both mesh or triangular-based data. So this is kind of what's being coined as convergent hybrid modeling. So we can revise mesh density, fix or repair problems with faceted geometry, and use features like holes, rounds, cuts, protrusions. So this allows us to rapidly create new concept designs, easily respond to change requests, and make simultaneous updates to multiple parts within an assembly. So we can treat multi-CAD data just like native files, supporting seamless collaboration with suppliers and partners. And then I'll say it, better sheet metal design. I think Solid Edge has a far superior sheet metal environment than all the other tools out there. So we don't want to compromise when it comes to sheet metal, right? Solid Edge provides sheet metal specific designs, features to allow you to easily add drawing details and automatically calculate material relief, and develop these 2D sketches with fewer steps and make changes at a very early stage of the sheet metal design process, all while maintaining that design intent. So we also have accessible industrial design. So we can bring easy to use integrated industrial design tools to your mechanical engineers and incorporate aesthetic design into your product development process. Using subdivision modeling, which is proprietary to Siemens and Solid Edge, Solid Edge provides advanced yet accessible industry design capabilities. Designers can create complex and high controlled aesthetic surfaces using Solid Edge's intuitive subdivision modeling tool set instead of the somewhat complex surfacing tools that are available in Solid Edge as well. This is suitable for users with any CAD experience level, allowing them to create highly stylized shapes with ease and just dragging cages around in a 3D model. So in the world of ramping AI for pretty much everything, including my refrigerator in my kitchen, Solid Edge also takes advantage of that AI-powered software that can understand you. So you don't have to be a programmer in order to use AI. Solid Edge intelligently learns your workflows to help streamline the design process with a predictive user interface powered by the AI or machine learning. So Solid Edge can predict what operations you are likely to want to perform based on the previous user's behavior, improving your downstream productivity. And then we also have interoperability for data across CAD systems. So in a recent survey, more than 50% of CAD users cite working with imported data as a top 5 challenge. And I think we all do it from one day to the next. So regardless of whether your design data originates in Solid Edge or other, Solid Edge makes working with it easy. In addition to the ability to leverage design data created in other CAD applications, recent enhancements to CAD Direct data translation and migration capabilities make it easier with you to expand the roster of supporting different formats. Whether you're switching from another CAD system, reusing legacy design data, or working with suppliers, Solid Edge makes working with third-party files as easy as if it were native data. And then finally, file sharing and collaboration from any device. So we can instantly, securely, and easily collaborate with colleagues, partners, and customers with Siemens' next generation cloud collaboration solution, which is Teamcenter Share. So this is available through your Solid Edge SaaS subscription, as well as online purchase or eligible for Solid Edge portfolio products. So this streamlined integration, powerful productivity features, and extended storage files to support you and improve communication and move projects forward from anywhere from any device. So just off the list there, that's a lot of reasons to make a change. So if that's not enough reasons, Siemens has put together a ton of easily accessible resources to kind of help you make that decision directly from that website. And at the end of this presentation, I can share the link. So if you have some questions about switching from SolidWorks to Solid Edge or other softwares to Solid Edge, they put together a really nice kind of Q&A section here on their website. So Solid Edge Portfolio offers the most intuitive and productive software solution, enabling you to accelerate all aspects of product development. So including 3D design, simulation, visualization, manufacturing, tech pubs, and data management. So if you're not familiar, there is also a free Solid Edge 2D software where users can view and mark up a lot of different 2D and 3D CAD formats, not just Solid Edge stuff. So there are some free options out there that you can kind of investigate and interrogate some designs from other platforms from Solid Edge for free. But we have easy to use 3D CAD software with a fast learning curve. So that's kind of one of the big focus points is, making the software so easy that you can just come in from another software and use it. Solid Edge, again, is based on that Parasolid offering continuity of data for SolidWorks users. So currently today, as we'll talk about here shortly, they basically are using the same modeling kernel. Synchronous technology, though, enables faster and more flexible designs, faster design changes, and a more intelligent data reuse, which we'll talk about here in a minute as well. And then we have options like bulk migration tools for SolidWorks parts, assemblies, and drawing files. And then we can also maintain the links and keep associativity of these part files to drawing files to assembly files. So we can maintain all of that associability from all the SolidWorks data inside of Solid Edge. So we don't have to relink that stuff if we use these specific migration tools. So let's talk about the current state of the CAD. The big conversation out there today is the kernel craze, right? The kernel issue. So this seems to be one of the biggest topics of discussion in the CAD world today, at least in the groups that I'm involved with. So as many of you may know, SolidWorks, Solid Edge, NX, Onshape, IronCAD, Sharp 3D, etc., just to name a few, all use the Parasolid kernel. So, but what you may not know is that Parasolid kernel was developed and is owned exclusively by Siemens. So in fact, Siemens Parasolid kernel is licensed to over 200 other independent software vendors for integration into their product, ensuring compatibility across more than 350 plus CAD applications via its Parasolid X_T data format. So SolidWorks actually being one of Siemens' biggest customers, Dassault's flagship product, CATIA, uses what's called the CGM or Convergent Geometric Modeling kernel. So this kernel handles kind of the core geometric and topological operations for creating and manipulating 3D models in CATIA. That CGM kernel is also used in all of the new Dassault's 3D experience applications. So CGM is a powerful kernel, but it's not Parasolid. So in efforts to cut ties with the Siemens owned Parasolid kernel, SolidWorks is pushing their customers to move to the 3D experience, meaning utilizing and working with this CGM kernel, sorry. This includes the SolidWorks platform itself here in the near future. So it will be transitioning to this CGM kernel as well. So while this creates a problem for all the current SolidWorks users currently, because the kernels are drastically different, they will be required to translate all of their legacy data from Parasolid to CGM. And we're not really sure what that looks like yet. But this is troublesome in many different ways. So a new kernel equals potentially new modeling workflows and best practices, not to mention the heavy task of translating all of your old legacy SolidWorks Parasolid data into this new kernel. And as we all know, there are always things that are lost in translation. Little Bill Murray callback there. So businesses have different reasons for moving between CAD systems, right? So Solid Edge provides different distinct solutions with capabilities to match these different reasons. So whether it's migration, multi-CAD, translators, etc. So today we're going to cover we can use Solid Edge to translate, fully migrate SolidWorks or Parasolid data, or simply open non-native files in Solid Edge. So we'll look at a couple of different approaches here. But if we're not looking at Solid Edge as the solution, and maybe we want to stick with SolidWorks and go to this new CATIA kernel, there are third-party data migration tools out there. So you may want to use these for SolidWorks, CATIA, Inventor, Creo. But Solid Edge also offers these specific individual translators and migration tools for each application itself. So one thing about third-party migration softwares, there's additional costs, right? We have software purchases, we have software maintenance fees, and then software consulting fees. And then hopefully it's compatible with where we're going to where we've been. And then the feature tree translation technology in third-party software can be quite fragile in my experience, and recompute errors often occur. So there's always kind of a risk at using these non-direct CAD third-party migration tools. So, and here's just a quick little kind of a few comments from some of our recent large customers that have switched to Solid Edge and kind of commented on the proficiency of migrating their legacy Parasolid data into Solid Edge. So, let me go back here. So one states that using Solid Edge gives us the ability to migrate our models as well as our drawings and maintain the associativity between the models and the drawings. So just because we're switching to a new CAD platform doesn't mean we have to go back in and recreate all this associativity from the drawing to the model or the drawing to the assembly. We are able to maintain that associativity between all of that. Another user commented that we have several fittings designed on a platform we used previously, and when we bring these files into Solid Edge, they are actually associative. So we can even import drawings from a basic 2D CAD package like AutoCAD, where we use our punch press. And then finally, another user maintains a lot of old 2D CAD, AutoCAD software data, as well as 3D data in a history-based 3D modeling software. The company can leverage that work to bring into the synchronous technology environment and quickly manipulate it with very little effort. So from kind of a three-pillar look here, these are the three kind of primary types of data migration that we can do inside of Solid Edge or with Solid Edge. So the first is just directly opening an individual file inside of Solid Edge. So Solid Edge gives us the ability to just do file open and then navigate to all these non-native CAD file types. I'll show you a picture of it in the next slide, but this is generally used for individual drawings, parts, and assembly. So maybe some stuff we're not really quite sure what the data looks like before we've opened it in Solid Edge. And this can be a little complicated because a lot of times we don't really know what the file is. Is it a part file? Is it an assembly? Is it a drawing file? Sometimes we don't really always get that extension type. Maybe it's been saved as a step file and we're not really sure what it is. So often we have to guess and presume what template it may be, whether it's a draft file, a part file, or an assembly, and then open a new file only to find out, nope, it actually wasn't an assembly file. It was a part file. So then I have to go through the whole process again and then select that part template file to open it up in. So there are some, steps that we'll have to kind of take in order to get the right template done. But again, that's kind of why we just use this first option as kind of the quick and easy option. And this is really used for small volumes of data, so typically just one or two parts at a time. But we do have access to a wide variety of data types that are supported in this fashion. So we'll look at an example here in a minute. But the second being the advanced design migration of parts, assemblies, and drawing files to Solid Edge. So this gives us a little bit more kind of depth to our translation and migration of the data. So we can use this a lot easier with larger batches of data. So we can pick an entire project or maybe an entire library, and it will it'll break down the data and kind of give it its Solid Edge converted file types. So This migrates both the geometry and the links between the parts, assemblies, and drawings. So this is where we can capture the associativity of these different file types from other softwares. So there are specific tools that just come with the installation of Solid Edge for SolidWorks data, or maybe you just have Autodesk Inventor data, or maybe you just have PTC Creo data. But these are all included individually in the Solid Edge installation. So we have access to all that inside of Solid Edge. One of the kind of caveats is that we need a license of the original software plus Solid Edge, or at least that's how it's been in the past, is we kind of have to maintain licenses between both in order for this migration tool to work. But there have been some drastic improvements in the Solid Edge realm that kind of, there's a workaround for that. So we no longer need an actual full-blown license of the original software plus Solid Edge in order to extract the data. And then third, there's a new kind of functionality inside of Solid Edge that's called CAD Direct. So this enables insertion of native files from systems like SolidWorks, Inventor, PTC Creo, CATIA, NX, JT, STEP, or any Parasolid for that matter, into Solid Edge assembly without converting them into a neutral format. So it maintains a link of the imported geometry and the original parent file. So if the parent file is changed, that it will be reflected and it can be updated inside of Solid Edge at that level. So we no longer have to have say a SolidWorks project with a bunch of files and then the equivalent Solid Edge files of those. So using this CAD Direct data, we're just showing and representing the SolidWorks file. I'll pick on SolidWorks here today. That SolidWorks either part or assembly into our own assembly without ever having to even save that to disk or manage it in any way, shape, or form. So the imported data can be used downstream for downstream tasks as well, such as applying relationships, assembly features, and as we'll see in a demo here shortly, we can actually even manipulate this non-native Solid Edge data using this CAD Direct functionality right inside of our assembly. Okay, so let's kind of break down each one of these methods just a little deeper here, and we'll go back to method one, which is just directly opening the individual files in Solid Edge. So as you can see here, we have a big list of file types that can be recognized and brought in, and there is some limited migration that happens with this just raw direct file open and then select your non-native Solid Edge CAD data. So you can see here we have SolidWorks and we both have options for parts or assemblies. Inventor, we have parts and assemblies. Pro-E, we have parts and assemblies. We can do an NX PAR file, IGES, STEP, SolidWorks. The list goes on. And we even have the ability to pull in CATIA V4, which is Parasolid, and CATIA V5, which I think was the version where they introduced the CGM kernel. So we even have some ability to open those files. We're just kind of limited to what we can do with them when we bring them in using this method. Obviously, there's kind of, as I mentioned before, synchronous technology allows us to directly edit the imported 3D CAD model. So this patented technology is unique to Siemens digital industry software. So it's only in Solid Edge and NX. So even though others have access to the Parasolid kernel, no one else has synchronous technology. So it's exclusive to Solid Edge and NX. So Solid Edge users can make intelligent updates and imported data as if the history tree existed. Simply just click and drag on features, add and edit dimensions on the fly, and there's no requirement to translate the feature tree or to have fully editable models. We can just pull in this dumb part copy and start manipulating it right then and there from the synchronous technology environment. So this applies to both data converted using the file open and data converted using that bulk data migration tools. So as I mentioned, when you install Solid Edge, you have these specific data migration tools for each one of these popular other CAD systems. So if we just navigate to where your installation of Solid Edge is, C program files, Siemens, and whatever version of Solid Edge you have, we have these different migration tools right here from the get-go. We have Creo, Inventor, Pro-E, SolidWorks. I think Inventor is on this list as well. I think this is an older version, but Inventor is also on this list. So we basically just fire up one of these migration tools, select our non-Solid Edge native data, and then the migration tool will do all the work for us. So an example workflow would look like this. So we would start off by opening the required SolidWorks parts and drawings using the eDrawler. So eDrawler is also just a free SolidWorks viewer that this migration tool will accept as like having the license and having SolidWorks and Solid Edge kind of running continuous or side by side. We migrate them using the specific embedded Solid Edge migration tool. So for this instance, we would be pulling in, we would be using the SolidWorks migration tool. And then once the migration is complete, we open to verify that the migrated files, everything kind of migrated over and we're good to go. And then from there, we finally just make quick and easy edits if they're required, and then to any of the parts or the assembly files, and then we just quickly update the associated drawing files. So it's a pretty easy process to work with these non-native Solid Edge files and manipulate them if we need to, or just quickly make a change to the part, and then that drawing just automatically gets updated, saving us a lot of work and effort. Okay, so let's talk about this third method, this new method within Solid Edge called CAD Direct. So what is Solid Edge CAD Direct? So it gives you the ability to insert foreign file types directly into the Solid Edge assembly. So instead of just doing, if you're in an active assembly, and instead of going to insert component and search out for some existing part file to pull in, we can actually use this CAD Direct command, which will import any non-Solid Edge file into our assembly environment. So it's useful for supplier collaboration. So maybe you have some parts that you put into your assembly that you don't really, you don't do anything with it other than it's just a part that you buy off the shelf and you put into your product, and it just but you want an active part of it in your model to really kind of adhere to that true digital twin of what your product looks like in the CAD environment versus what it looks like on the shop floor. So we want to kind of replicate that the best we can. So this avoids the need to translate these files. So this actually eliminates the translation and migration step. You can just use the CAD Direct command, search out to your SolidWorks assembly or part file, and pull that directly into the Solid Edge assembly, and no need to save the file as a Solid Edge compatible version. So again, it's just looking at that source part and then giving you that inside of Solid Edge. And again, it's associative. So if that parent file changes, then we are directed that change is shuttled over into Solid Edge, so we can maintain the changes that happen from that source part or that parent part. So again, associativity is maintained between the CAD Direct geometry and the parent files. If changes are made to that parent file, they are reflected in the CAD Direct by using the update CAD Direct geometry. So it doesn't just give you an instantaneous like notification that there's been a change to the source file, but you do have like a little indicator in the Pathfinder of that CAD Direct feature that there is an update available if you wish to use it. And then from here, you would just choose to either update that CAD geometry if you wanted to show that new change in the part, or you can break the CAD Direct link. So you can basically just ignore the change that happened in the source part. Maybe you want what you already have in the design, and you don't want to have to bother with that. You can just break that link altogether directly from that feature in the feature tree. So basically any kind of change that happens to the geometry of that source part. So whether you added a part to the assembly, you removed a part from the assembly, you added something to a subassembly, the part's position has changed, the body added to the parent part. These are all types of changes that Solid Edge will identify and notify you that there's a change available, and then you can just choose to pull that change directly into your file. So you don't even have to re-pull in that part. It'll just automatically update it for you. So, and again, you have to save the assembly file for the change to be reflected. So if the parent file would need to be saved in order for it to finally recognize that change has been made. And again, you can break the link that deletes the link between the parent and the CAD data component, CAD Direct component. And then after you break the link, changes from the file would not be associated with Solid Edge anymore. So this is something that's permanent, but there's an even newer command inside of this command that allows you to freeze the link. So maybe you know there's some changes coming up, but you don't want to be notified that they are until you're finished with doing your specific role in the project. And then at that point, you could unfreeze the link, because if you break the link, you can't relink it. You would have to delete the part and then pull in the newer version of that CAD Direct part. So they're adding even additional kind of improvements to this process to kind of give you a little bit more flexibility in the command. And then obviously we can maintain the downstream features for CAD Direct. So this is an NX example. So even though Siemens own both Solid Edge and NX, they are different file types, even though they're both parasolids. But so if we have an NX file and then we've pulled that into our Solid Edge assembly using that CAD Direct function, if that NX file changes and that NX file has PMI associated, even the PMI will update along with the geometric changes that happen to the part. So even that PMI is adjustable and accessible from within the CAD Direct command. So let's look at a quick video, or let's look at a quick demonstration of kind of what this process looks like. Again, it's very easy. So I'm just going to create a new assembly, and I'm just going to start with a blank assembly here. And then again, instead of just going to my insert component, I'm just going to utilize this CAD Direct command here. And as you can see, I've got this working folder here, and you can see that these are truly SolidWorks parts. I haven't converted these into a Solid Edge workable part. These are raw SolidWorks files that I'm going to just open up inside of Solid Edge. So I'm going to just select the top level assembly, and you'll see almost instantaneously we are presented with the SolidWorks part or assembly inside of Solid Edge. So I didn't have to migrate, I didn't have to translate, I didn't have to do anything, and it's not just a part copy. This is of the full-blown assembly with each one of the individual components listed here, but as internal components. So notice I didn't have to save this file. It still kind of shows it as the SolidWorks assembly and all the SolidWorks parts, but it did generate the part equivalent of it. So the Solid Edge equivalent is captured here, but again, it's not saved anywhere else except for inside of this assembly. So as I use these CAD Direct commands and pull in these assemblies or sub-assemblies or parts, the only thing that's really changing is my assembly file size. I don't have a version of SolidWorks files and a version of the Solid Edge files. This really kind of limits my manual process of having to kind of manage all these files. Again, and I didn't just get the raw parts, right? Like all the cutlers, the textures, everything from the SolidWorks and part file came over. And if anything changes to the SolidWorks parts, I would be prompted to update. And if I just right click, I've got a couple of options here. Again, I can update the CAD geometry if I want to show those changes. I could freeze the CAD link. This is a new command new for 2025, which allows me to just freeze it and then unfreeze it when I'm ready to make the changes. Or I can just simply break that CAD Direct link, and it's no longer looking at the SolidWorks files for any types of changes. And the great thing about that is if I break the link, then I still don't have to save this out anywhere. All these individual parts are still just captured within this one assembly file. And again, I don't have to really manage any of that data. But again, this is a SolidWorks file, but we're inside of Solid Edge. Let's say we want to make a change to maybe this part here, and we want to utilize that synchronous technology just quickly to make a quick edit on maybe this Canon edge here. And we're just going to extend it out. Something to that effect. Nothing, no big change, but as you can see, within 2 clicks, within a minute time frame, I was able to bring in a SolidWorks project, manipulate that SolidWorks project, all without having to do any kind of migration or translation. So pretty cool, pretty powerful tool. I really love this CAD Direct tool. It helps me out a lot, and I rely on it quite a bit. Okay, so we'll just talk briefly about the actual data migration tool. So again, we're going to pick on SolidWorks today. So this is, we have a SolidWorks legacy data, and we want to start using this in Solid Edge. And we want to maintain all the associativity. We want to maintain the, the file properties, the everything. So when we choose that SolidWorks data migration tool from the C program file Siemens installation location, you can see here it's pretty easy to use. We basically just kind of point out to where the directory that contains the SolidWorks data. And you can see we have options to bring in and migrate the material database. We have the whole database that we can pull through. We can pull through any templates that live inside of the SolidWorks folder structure. And we can also choose, once we bring this data into Solid Edge, do we want to present it in the synchronous mode or the ordered mode? Another couple other settings and options here. So we can export SolidWorks draft files as either a DXF, PDF, or both. So again, it doesn't just directly convert your SolidWorks drawing into a Solid Edge drawing, but it does generate a DXF that you would just open up in the draft environment, and then you would just save that as a draft file. So it's just one additional click to make that DXF into your Solid Edge compatible drawing that would maintain the associativity between the parts and the assemblies that they're presented for. And then again, this tool is great for the bulk migration. So, it basically brings over everything. So we can see that the assembly structure has been migrated with the same sequences that it presented in SolidWorks. So even the assembly configurations have been migrated. So I will state that configurations is a funny buzzword because the different softwares consider configurations two different things. And I'll just briefly explain that here. So even though they both have configurations, they have different terms for them. So in Solid Edge, the term configurations are used to display different design configurations or display states of an assembly, maybe a different isometric view with a couple of parts either hidden or suppressed or in a different position. That's what Solid Edge considers a configuration. Whereas SolidWorks uses a configuration is what Solid Edge would refer to as an alternate assembly. So they were just different positions of an assembly environment. So Solid Edge has the ability to understand that this configuration, even though Solid Edge has something else called configurations, it knows and translates it into an alternate assembly where it maintains all of those SolidWorks configurations into alternate assembly options. So even there, we have some ability to kind of change the terms to make it work inside of Solid Edge. And then again, just to mention the maintaining links between the parts and assemblies and the drawings. If we use this migration tool specific to the CAD software that we're coming from into Solid Edge, we have that easy maintaining of the views of the parts or the assemblies at the draft level. Okay. So when it comes to SolidWorks parts, we're able to again migrate the parts along with their part file properties, whether they're multi-body models, part configurations, and as we mentioned before, the whole databases and the material databases are also migrated. So this is just a quick list of the different things that come from SolidWorks into Solid Edge. So same with the assemblies. There's some capabilities for assembly components and the positions, the file properties or the metadata for the assemblies, those configurations, all the relationships are maintained. And then assembly patterns are recognized as well inside of Solid Edge. So again, it makes that migration really, really painless. And then for the drawings, with the help of the migration tools, we're able to get the drawing file data along with the file properties. Drawing views, which are linked in the models, are also migrated accordingly. We get the 2D styles too. So when we're using, if we have a view that has a section view or a broken out view or an auxiliary view, all those views are kind of maintained and associated. And then for section views, the hatching style will be maintained from SolidWorks to Solid Edge as well too. So that's all supported. So when we transition from SolidWorks or any other CAD platform to Solid Edge, there's a really cool tool that not a lot of people are familiar with, but I use it. I've been using Solid Edge forever, and I still find myself utilizing the command finder inside of Solid Edge. So again, there's some different terminology and different tools. So what Solid Edge has done is they've actually taken, for example, in SolidWorks, a fillet, a round is what's known as a fillet in SolidWorks, but in Solid Edge, it's called a round. So if you type in fillet, the command that you're used to, it will show you the equivalent, the Solid Edge equivalent. And not only will it give you a match but it will also highlight and show you exactly where that command is on the command bar. So again, this is a great tool for either finding the equivalent of a term that's used in another CAD platform to Solid Edge, because again, there are a lot of terms that are different from one tool to the other. But it gives you the equivalent, the Solid Edge equivalent of that tool, and then shows you where that tool is at. So again, for people that are brand new to into Solid Edge, this is going to be a great tool to utilize. And it's just there at the top right-hand corner of the screen, and you can use it in any environment. I'll touch real quick on just the PLM side of things. So Teamcenter is a Siemens solution for PDM or PLM. So, we use Teamcenter. We recommend Teamcenter for, groups of designers more than 10. So from 10 to 1,000 designers, we would recommend Teamcenter as your kind of Siemens solution for the PLM. Solid Edge does have a built-in data management tool, but we recommend it for very, very small groups of users. But it's very basic. It's just check in, check out, revise, where used, and maybe some one-step release workflows. But Teamcenter is kind of the core Siemens solution for PLM. So it's really strong for multi-CAD data management capabilities. So it is integrated with SolidWorks and Solid Edge. So there are businesses out there that use Siemens Teamcenter with their current SolidWorks environment. So Teamcenter has integration for a lot of other CAD platforms out there, SolidWorks being one of those. So users can support a transition from SolidWorks to Solid Edge, and likewise, Siemens Teamcenter and Siemens Solid Edge they're built on the same architecture, so they are even more seamless than any other CAD integration that Teamcenter offers. So if you're using SolidWorks and Teamcenter and you move to Solid Edge, then that Teamcenter workflow is not going to look any different for you. All the data is already going to be there, and it has the ability to recognize the difference between SolidWorks and Solid Edge files and then manage that accordingly. And just a quick look. So if you are one of those businesses that are using SolidWorks and Teamcenter, you can see that you get really not a whole breadth of capabilities that you would have inside of Solid Edge. So for instance, SolidWorks and Teamcenter integration, you don't have electrical CAD functionality, simulation, product configurator, technical documentations, things of that nature. Those are not compatible with the Teamcenter integration to SolidWorks. But if you move to Solid Edge, then you see now you open up all of the functionality for Teamcenter because again they're on the same ecosystem and architecture, so a lot more compatibility and functionality if you're using Teamcenter and Solid Edge. Okay, so obviously it all comes down to money, right? Like, what's the return on investment if I move from SolidWorks or another CAD platform to Solid Edge? So Solid Edge has actually built a tool that helps you kind of understand your ROI when switching to Solid Edge. So I just kind of briefly talk about how it works. There is a Solid Edge ROI calculator that I can send a link to if you're interested in kind of looking at how much money you can save by switching from SolidWorks to Solid Edge. I can send you that, and it also comes with an ebook to kind of help you understand how it all works. But I'll just kind of give you a brief kind of rundown of what it's looking at. So it's looking at 8 KPI zones that you can track and confirm your ROI. So it's going to look at the design to support new products. It's going to look at the time that it takes to re-engineer of existing products, reusing design details, how long it takes to create bill of materials, collaborating and mobility, creating, checking, and editing drawing files, and then editing the imported and supplier models, and then creating documentation. So those are kind of the pillars, the 8 zones that it's looking at to kind of base this ROI. And then just kind of looking at the interface of this ROI. So basically it's just going to look at the 3 pillars, right? Like, so for, we want to input the number of engineers, right? How many design engineers do we have? How many hours per week do they work? And then what's the percentage of time that they're using the actual CAD tool each day? And then for each engineer, we'll break it down and say what's the number of new design projects that each engineer does per year. the number of change orders that they process each year, and then how many parts are in their project. So we can kind of look at that section too. And then when using the CAD tool, how much time is spent on either designing to support new products, that re-engineering of existing products, searching for existing parts and CAD documents and CAD data, creating bill of materials and managing the bill of materials, and then planning and conducting design reviews, creating, checking, and editing drawings, and then editing that imported and supplier model. So it's going to kind of use these elements to kind of determine the value or time that you will save by switching to Solid Edge. So again, I can send this to whoever's interested in seeing this, just to get an idea of what kind of savings or cost avoidance you'd be looking at. And then some of the results. So we would be able to see, the highlighting impacts of Solid Edge on productivity. So again, that core design areas, we can see the increase in new production time or design time. A wider productivity areas is creating work instructions, manuals, bill of materials, things of that nature. And then basically the benefits achieved by faster design, faster engineering changes, and easy to reuse 2D and 3D CAD data. Okay, so we'll just look briefly at a couple of recent success stories or case studies from manufacturers who successfully transitioned from SolidWorks to Solid Edge. And I'll just kind of briefly talk about, I won't get into the details of each place here, but some of the common challenges, solutions, and the benefits that each one of these guys saw. So for this particular example, the challenge was combine two engineering teams into one, and then maintain on-time product design and delivery. So the solutions were to standardize onto one single CAD solution, which was Solid Edge. This is pretty typical where we'll have two teams or three locations that a business has, and each one of those teams are using different softwares. So obviously standardizing to a single CAD solution is always going to be the best, whatever CAD platform it is. Apply SolidWorks to Solid Edge bulk migration tools. So again, using those migration tools, and discover the benefits of synchronous technology to speed up the design. Again, that synchronous technology is only available in Solid Edge or Siemens products. So that's the real kind of leverage that the customer would have, or the advantage, the competitive edge. And then some of the benefits were the cutting design time in half, which is pretty huge in my opinion. Leveraging skills of the SolidWorks Top Gun designers to implement into the Solid Edge workflow. So really very little learning curve. And then implementing best design simulation technology for the combined team. And then discovered synchronous technology, again, was another benefit, 80% of projects. So they shifted from an order-based, history-based modeling environment to 80% of the projects now being synchronous technology based. Friedman Seating, they also, some of their challenges were very short lead times and many product variants. And the solution was to transition from SolidWorks to Solid Edge, the Parasolid compatibility with other CAD and CAE programs, and then strong assembly modeling, sheet metal, and weldment design functionality. So again, those are kind of individualized environments inside of Solid Edge. And then some of the benefits were better availability to meet short lead times, virtual prototyping replaces physical testing, and then more design reuse, part count down by 50%. So again, reducing the file sizes and part numbers that we have is pretty impactful. And then easy data exchange with major customers and outside analysts. And there's one third. I'll go ahead and skip by here based on time. So in summary, we looked at the current state of the CAD and learned about the kernel craze happening in the CAD industry at this moment. And we saw some really valuable, ever-growing SolidWorks data migration tools to help us transition into Solid Edge near flawlessly. And then we learned about some really cool ways of getting SolidWorks and other non-Solid Edge native file types into Solid Edge without the need for migrating or translating or managing extra files on disk that we get from suppliers or vendors.